week 4, and hopefully it's a month into the semester. I gave you the floor plans, the project details, we distributed projects, so let's go through the steps. Hopefully within the next 2-3 weeks, you get the heat loss done for the house. And I also offered that if you don't like the floor plans you have, you can go and pick a floor plan online. Question?
Based on like last semester, what we handed to you about those, you think we could just get those pictures to see?
Yeah, I'll do it. Marcus keep reminding me and I forget it. Doing the old
Oh,
project.
yeah, but, I don't think you gave me a floor plan, I don't think I was here that day.
Okay, so do you have a group?
Yeah, you was just
Okay,
telling me.
okay. So each group has a floor plan. So again, every Wednesday afternoon, I'll finish whatever lecture we didn't finish, then we'll sit together and try to work on it. It should be really fun project. It starts becoming fun if you were at the last 2 weeks and we have to cram everything in one class. That's when it really becomes stressful. So if there's one thing to learn from this project is to work little by little, take your time. Now we have in front of us at least 12 weeks, which is plenty of time. So we finished the calculation, and I also suggested if one of the group brings a computer, I can help you out with Excel. Very, very useful tool. Will make your life much easier, and I already have a template ready for you. So we said before we start, first of all, you get the floor plan, get the details. What is the layout? Number of floors? What is the heated and unheated space? And I said you can choose. You can choose. Of course, you cannot leave a bedroom unheated. If you do that, you're gonna have to mothball it. I would like to design to have everything heated. So for the heated and unheated, we are talking about either the garage, hobby room, porch, stuff like that. So you can decide on that whether you want it to be heated and unheated. House orientation, is it facing north, facing south? That kind of makes a little bit of difference. Building material, what are the walls made of? The floor, you can pick again. And please try to pick something not really porous or something that really uses a lot of heat. Otherwise, you'll have to go back and insulate it. We're trying to design a very good, tight design. So if you put a floor that have a big U factor, then you might have to go back and put some insulation. Last semester, we saw small houses, one floor with 60,000 BTU/hour. That is a lot. But that was just to practice the numbers. So now we're gonna go and pick some good material. If the wall that is designed for the house doesn't have enough insulation, we can add some insulation to it. And this could be the case if the house was built to be constructed in the south. Probably they don't have a lot of insulation because there's not a lot of delta T. For us, we need really good insulation. It gets so cold outside. If you are building a house in Springfield, outside is 0. If you want to keep the house at 60, that's big delta T. The bigger the delta T, the more you will lose. So think of this equation as you go ahead. As delta T goes up, this will go up. As U goes up, this will also go up. And the area usually is constant. So, I mean, the area is the area. You cannot change that unless you really, I don't know what you're gonna do. But this is all usually constant. So, either you add material, and this also is not gonna change because this is what you have. I mean, it's where the house is located. So, hard to change. Also constant. Between inside and outside. Inside for the coldest day or the hottest day. So all you have is to add insulation material, which is 1/R. So you keep increasing the R to reduce the U factor. Geographical data, location temperature. Western Mass usually we go with 0. Boston is different, a little bit warmer than Springfield. Why?
It's by the ocean.
The ocean. Usually when you are next to a very big body of water, it kind of offsets the temperature. Proximity to water, that also has to do with moisture, what kind of insulation you can use or you can. And some of the cheaper stuff, they have issues with water. So you can still put some cheap insulation that will absorb moisture, but over time probably it has to be changed. and think with low term. I personally like things to be made well from the beginning, so start with very good insulation. Shade. So you can provide your own shade if you find, like, for example, your house has a lot of big windows. So you can say, okay, I have big windows, but in the summertime, okay, they're facing south. I'm gonna put some trees that will cast shade on those windows for the entire summer. That's acceptable. So what is your shade? I would say the second thing, we label the rooms, and I saw everybody did that. Just give them a number, bedroom 1, 2, and 3, or name the rooms so you can put them in the sheet in an organized way, so you know what are you heating, what you're not. Again, we number the rooms. So as you can notice here, I did not heat this bathroom. I did not heat the laundry room. HVAC room, you do not need to heat. And not heating the porch or these closets. Closets you do not heat. It's part of the room. Usually they are closed, they remain cold. You do not heat closets. So what is heated, what is not? For this house, we said there are only 6 rooms to consider. There's a walk-in closet that is not heated. There are no windows, there's no infiltration. And usually the closet gets a little bit heated from the room. Some heat will go into the closet through the roof. The hallway is not heated again because it opens up to the other rooms. And I don't know who was telling me, I think it was you, that some rooms get hotter than others. And that's why when you see in some houses they have vents in the doors, either top and bottom. So you can close the door and the air will still circulate. Some rooms, if they are close to the boiler, and you have one loop, one after another, the first 2 rooms will get all the heat and become extremely hot. Meanwhile, the other side of the house is extremely cold. That's why it's always a good idea to have a parallel connection. You have one pipe for the hot water, one pipe for the cold water, and you connect every radiator in parallel. We'll talk about that in piping schemes. HVAC room and hot laundry room is not heated. Dining area and living room, it's a choice. I combine them into one area, but you can isolate them and put an accordion door or curtain to isolate the heat. Kitchen will need some heat because it has a window and does not have enough space to exchange heat with the other place, with the other side. The porch is included, yet not heated, so it will be treated as unheated space. However, it's different temperature. If you look at walls in your book, it will say wall, exposed wall, or wall through unheated space, and that also makes a difference. These are the factors for infiltration. These are rough approximate for new structure. Again, if you want to get the actual heat factor for all construction, the best way to do it is what? Use blower door test. So these are only general numbers. That it could be more, it could be less, but these are provided to ease our calculation. If you want to get the accurate amount of heat loss in a house through infiltration, you should go and do a blower door test and find all the opening in the house. And we said the house might have been built a certain way and a lot of things has changed. You added with new equipment, you added new receptacles, and it has some holes in the walls, and that could also be an issue for infiltration. So, and we said heat loss is a combination of 2 things, infiltration and transmission. So first, you have to consider the the infiltration, then the transmission. If you design your house based on one thing, you can have very solid walls that do not conduct a lot of heat, but the house is very porous. And that's not gonna make sense. If the windows do not lock very well, you're losing a lot of heat. You can go actually just touch, in a winter day, you can touch the window and you can feel the frames are very cold, or they're seeping some air. You can go with the smoke machine and see the smoke coming in and out, even in not a very windy day. Any questions so far? So this all repetition, we did that. We just reiterated. Step 4 is transmission heat loss. So let's go back to step 3, which is infiltration. So this is transmission. And this is infiltration. What is the equation for infiltration? Factor. That's it from here, right? Times volume times delta T. delta T are the same. The volume is the volume of the room, which is width, length, and height. So, and the factor you will get from here, based on the number of sides of window. So if we have a, let's draw something. So if I'm using this table here, and I'm going to use with storm sash and weather strip, meaning that it does not leak as much. So, Jason, what factor will I use for room number 1? Can you see?
The first one? Or no, sorry, the second one.
Huh?
Or no, yeah, the first one.
Yeah, the first one. The number of sides with the windows and doors, which is 1. So I'm going to use 0.1012. What about room number 2?
Number 2.
Eric?
0.018.
Yeah. What about number 3?
0.0.
So because this is have 3 sides, 1, 2, and 3, has 1. This one has 2 sides.
What is the difference between those two tables?
Huh?
With or without?
So
the
this
storm?
one is without. It's not weather stripped. It doesn't have storm sash. This one has a storm sash.
What is that?
Huh?
Storm sash, like, what is that?
From what I know, it's some kind of enclosure for the window. When you close it, it has very extra lip to close that. That's a storm sash. Weather strip means you have all the sides caulked and sealed. Question.
Does the film, the film or the screen?
Yeah.
People usually have
Yeah.
outside the windows, does that provide any type of like?
Yeah, that's actually excellent. If you have a really window with single pane that does not have a lot of insulation, it's good to just shut the window for the winter, put the film on it. It does reduce the infiltration significantly. It also reduces the transmission as well. So that's useful thing to do for the winter at least. Very cheap, inexpensive, easy to apply. It's a sticker, put in the window from the outside. It does look a little bit ugly, but deal with it if you have to see it when you heat. Okay, so this is how we do the infiltration. The factor you got, the volume is the volume of the room. If you have a closet in the room, I don't think you need to include the closet volume, so keep the room by itself. Even if you do, it's not going to be that much. Okay, so include the floor on top of unheated space. So if the floor is on top of unheated basement, you're gonna lose heat from the basement, right? To the basement. Yeah.
If you don't have window or door, you don't have to count.
No infiltration. No infiltration. So unheated space, crawl space, basement. If it's not heated, you're going to lose some heat to that floor. Cantilever extensions. What is that? So if you have a floor, let's imagine this house here. This is basement. This is the first floor. And it sticks out. So think about that. So the heat loss to the basement will be different than the heat loss to the outside. So you have a balcony or the whole room is sticking outside to the cellar where the floor is going, and that's going to be a different area. Do not include floors over unheated basement or floor space that has exposed heating pipes. Why? Because delta T will be almost 0 or very small. So you do not include that. For concrete floor, if the floor is below grade, use the area, and if it's above grade, use the floor perimeter. What does that mean? So if you have concrete floor, and probably some of you will have concrete floor. Let's go over there. Let's think of this house area.
Are you including the thickness of the concrete
There's a number for it in the book, for concrete.
If it's, so if it's below grade, you're not worried about the walls, you're worried just about the floor.
That's also the floor now.
Yeah.
So let's say this is the basement, it's above grade, which means like it's not buried. So we're gonna use this floor, we're not gonna lose a lot of heat to the ground. So for concrete floor, if the floor is below grade, use the area, and if the above grade, use the floor perimeter. So let's say it's above grade. What does that mean? That if I look at it, this is my concrete. So I'm going to use the perimeter in this case, which means for the heat loss, I'll use the perimeter, which is this distance, not the area.
Oh, that's what you're saying.
Yeah. If it's below grade, use the area. And if it's above grade, use the floor perimeter. So this is above grade. Below grade, this is what we mean. This is the ground, and I have it's going to be below grade. So then I will use the area. So this is case number 1, above grade. Okay? Question? So 2 cases for concrete. And again, in the book, there's an example. You can look at the example. If you're in doubt, ask. And when we do below grade, this is gonna be the first floor here for the basement. And you wanna heat the basement, there's a calculation for this wall. Because you're gonna lose heat to this side and this side. And it's not going to be the same. Losing heat to the atmosphere or the air is different than losing heat to the ground, especially wet ground. Question. Again, you're not gonna remember all these things, but case by case, when you go through it, you can look it up and think about it. I'm just giving you options to just start like thinking about options and what will happen. So ceiling, below, unheated attic and floor. Makes sense? Because if I have an attic that is not heated, what I'm gonna do, I'm gonna lose heat to that attic, so I have to include that ceiling. Only include walls that are facing outside. Makes sense? Because outside is colder than inside or hotter. Big difference in temperature. Walls shared by other heated rooms are not included. I think we are clear about that because I did that last semester. Those are treated as cold partition facing factor. If it's shared by heated room, you don't have to include it. If the room is not heated, there's something called cold partition. Let's say there's a wall facing the garage. The garage is not heated, but it's not going to be the same as the outside, right? So we have unheated space. If the floor above is heated, then there is no heat loss to the ceiling. Make sense?
Yeah.
Same temperature, we're not going to exchange heat. If the floor below heated, again, there's no heat loss to the floor. So it also means if you're sandwiched between 2 floors that are heated, there is no heat loss from that side. That's why we said if you live in a building and you're in the 2nd floor, 1st floor, or 3rd floor, turn the heat on, you can just
Yeah.
have less heat loss. So something to consider when you rent a place. Also, it's really good to be in the top floor. If you have a 5-story building, the higher you are, the better. Because everybody's gonna keep accumulation of heat unless they insulated the walls between, the ceiling, which they're supposed to for many reasons. One of them is heat loss, and the other one is what? Noise. So you know that expression, waiting for the other shoe to drop?
Okay, so
Well, they always say waiting for the other shoe to drop. Well, the expectation came from people living in New York City in buildings with floors, and you always somebody comes working the graveyard shift, they took off one shoes and you hear the bang on the floor and you wait for the other one to fall. So you're waiting for something expected, so. Because again, there was literally almost no insulation between floors. Question?
If you have cold rooms inside your house, even though they're interior walls,
Yeah,
not on the outside wall.
yeah.
Since transmission goes hot to cold.
Yeah.
Would it still try to would it still, the heat
Yeah,
would
but
try to get into
yeah,
that cold
but
room?
eventually, once it's hot because it's losing heat to any other place. So if it's trapped inside the house, usually you do not need to heat that. That's why you always put the thermostat in the middle of the house. So by the time the thermostat gets that heat, the whole house has been completely heated. Unless the hallway has a window in it or has a lot of ventilation, you do not need to heat the hallway. Again, think about always in Q equal area, it's a changeable utility. If there is no utility or very small, you're not going to have a lot of heat transmission. Again, we can always use kind of common sense during that. Some cases, it's a little bit more involved. If you have below grade, above grade, how do I heat that? How much heat am I losing? And again, it's really a bummer when you think you got it tried and you install stuff and you find out, hey, this person not getting heat at all. I really missized that. Of course, you can always fix that somehow. You can manage to fix it, but it's good to get it done from the first time. So 5, we add both infiltration and transmission for each room. So once we finished all the information for each room, we got the infiltration and transmission for each room, we added all together, and we have the heat loss for the room. And if it's a bedroom, we add, for bathroom, we add 20%, because we require more heat for bedrooms and bathrooms. For bathrooms, because there's a lot of latent heat, a lot of moisture, and evaporating that moisture will take up either heating or cooling, so we add 20% for bathrooms and 20% for bedrooms. They require more heat. 15 here, but you can go up to 20 for bathrooms and bedrooms to make up for latent heat and also additional heat, because again, you want bedrooms to be a little bit warmer than the living room, especially in the middle of the night. So you want to have the ability to keep up with that heat. So 15%, some books 20%, not a big deal, but add a little bit of allowances for bathrooms and bedrooms. So 7, 6, you get 6 and 7. So 7 steps mostly, you'll be done with the heat loss. Everybody get that? 7, you add all the rooms together and add again another 15% for cold startup and extremely cold days. So 15 for each bathroom and bedroom, or 20, or at the end you add them all together, then you add another 15%. That 15% can be used for hot water, if you have an auxiliary system, it can be used for very cold days, or if you left the house at 50, for the weekend you come back and you want the house to heat up from 50 all the way to 70. So you want to get 15%. So there are some calculators that does that. I have a few of those. There is plenty of them online. There are links. You can go and download that software on your computer, on your phone. It does that for you. But I'd rather you start to know how to do it by hand, again, so you know what's going on behind the math. And also, those software don't give you all the options, so they'll give you one wall with kind of already built wall. So what happens if you want to add insulation? So it gets a little bit tricky. And also, it gives you wall with usually square or rectangular wall, what if you have something different? So it's good to know how the software is working. And some of them are free, some of them you have to purchase. Here's an example. I think this was one of you guys' projects. Small house, ranch, 1 floor, not that heated. So this is the sheet I did, an Excel sheet. If you look, you have access to this sheet. This is 1 room total, which basically I mimic the sheet that you have on the heat loss. So in the beginning, you have to put the dimensions. You plug in your desired indoor temperature, put it at 80. the maximum. Outside was 10. So this will be calculated automatically, difference between them. The volume will be calculated automatically, which is length times width times height. The U factor you have to input. And DD will propagate based on this number, so you don't have to put that. So all you have to do is put your factors, and it will do the math for you, and it will add the total BTU for that room. Ceiling, floor, slab, if any, if not, you just put 0. If you multiply anything by 0, what do you get? 0, so it's not gonna happen. Doors, if you have doors to the outside, otherwise you can put 0. And for the walls, you have to calculate the net wall, which means you will subtract the window from that. So whatever window should be subtracted from the walls. So this is one example. I got 22,000 BTU for that room, room 1. I got the house information. Said it's in Springfield, and design temperature from the outside is 0. Design temperature on the inside is 70. U factors were obtained from the H22. You can find the U factors anywhere else. The J manual, engineering toolbox, many websites have those U factors. Selections for all the material from the book. So I get the factors, that's what I'm looking for. And it's really good to know what did you choose. I get that factor, put the table and the section. That's where I got this number. Factor for the ceiling, factor for the basement, factor for the windows, and the factor finally for the doors. So a lot of you did that already last week for the project. So we get the material, we get the selection, we're done with it. We did step 2, okay, that is step 1. Step 2, we number the room, so we know which room are we talking about. 6 room, again, this is what we decided, what is heated, what is not heated. We're not going to heat the hallway. We're not going to heat the HVAC room. We combined both the living room and the dining room. The kitchen will add some heat, and the porch not included, and not heated. So it will be treated as an unheated space. So here's where you put all the numbers, and I think there's, in the book, there's this example printed out. So you know where everything came from, and it will help you know how to fill in this Excel sheet. You can build your own as well. It's just very convenient not to have to do the math by hand. And I think I locked these cells so you can change the formula. If you have to mess them up, I'll show you how to do it. It's very, very simple.
The only ones you didn't lock are the ones for the wall.
Yeah, because the wall is it could be different cases. So, again, it's very small. Yeah, you put the inside, outside, room dimensions that you get from the floor plan. For room dimensions, what if you you round up to the next quarter? If you have 11 feet and 2 inches, you're gonna go up to 11.25. So try to round to the next quarter of an inch. For dimensions, so if you have one inch, you go up to a quarter of an inch, a quarter of a foot. Because you're gonna see foot and inches. So 2 inches, go to a quarter of a foot. You always round up to the next quarter of a foot, makes things a little bit easier. 1 foot is 12 inches. It's a bit confusing. So room 2, I think some of them you put 1 or less, whether it's a bathroom or bedroom. And if you put 1, it will automatically add 15%. It's the new version.
Where can we find that in the book?
This is actually, it's in the book, and also it's in the blackboard under references. You'll find the calculator there. So download it, rename it, and start filling the blanks. And if you want to do it by hand, you're more than welcome to. You can get a sheet and start filling the numbers. I don't mind, but it will be more convenient to use this. Room 3, same thing. 4. And this also will give you an idea where are you losing most of your heat. So if I want to really reduce the heat, I will look at the ceiling and floor. So probably I should put some insulation in there to reduce that from 10,000 to something else. Otherwise, filtration is not that bad. Slab, what else? Windows is not that bad, very small. I have really good windows. No doors. So mostly I'm losing heat from the ceiling and the floor. So that's something you can think about and add some insulation to it. Kitchen, dining area. So this example is also available in Blackboard, so you can look at it. Also in your book. So at the end, the program added everything together. I added all the rooms together, which was 60,000. Add 15%, so around 70,000. So usually I'll buy a boiler around 70,000 BTU, which is a big difference between 120 and so on. And you can also reduce that a little bit if you go back and insulate the floors and ceilings. So you can say, okay, we can redo this project, but we're gonna have to invest $2,000 into insulating the ceiling and floors. Or you can say, okay, this is the boiler need for the existing house, and you get away out the cost, how much will it cost you? Is it financially attractive or not? So then, this is the heat loss and filtration. What else you need to add is ventilation. We said before that it's good to have mechanical ventilation in the house. It's based on the number of occupants, how much CFM you need for that house. This is the formula to know how much heat you're gonna add for that insulation. So how many CFM do you need for each person? 15. What is delta T? And what is the heat capacity of air? So if I want to do that, if I want to add that to the heating load, usually you don't have to, it's not that much. But what is the BTU for ventilation? Let's say 6 people live in that house. So 1.08, 6 times 15, what is that? 90, yeah. Times 90 CFM, times 70 degrees, that's temperature difference. If I do that, that's around 6,000 BTU hour for infiltration. That's assuming we're just gonna have a fan exchanging air all the time with the outside. There are heat exchangers that will not have you lose as much temperature, but that will be enough because we already have 15% extra, so that should be good. If you have more occupants, probably you'll have to invest in more in filtration. Any questions? Seems doable? We're gonna keep doing that, and repeating those information. But then, it seems like common sense, right? Like, it's just a little bit too much information. But as you go along, you think about it as you go along. Don't think about the whole thing. Let's think of it wrong way wrong. Let's deal about this room first. Second room, I'll move on. And eventually you'll be able to do the whole thing probably in 1 hour. I kid you not. Just the first time is a little bit tough, but then you kind of develop the kind of the skill for it.